All right, guys, how's it going? This is MS Paint IDE, Programming in Anything, presented by yours truly, Adam Yarris. This is going to be a little bit of story time and some technical stuff, so let's get into it. First of all, it doesn't update anything. All right. Technical difficulties. It shows that it's updating on my presenter notes, but it does not in here. All right. Yeah, one sec. Pause.
Have your presenter notes here? You can just back to it.
You're so smart.
So just present with the original.
Yeah. All right, cool. Thank you. Thank you. All right, we're back. Technical difficulties are good. So who the hell am I? I'm a fourth year. Wow, I go to RIT. That's crazy. I'm a stinky CS major. I know. Sorry, but I know. Boo. It's awful. I don't like it. I'm a full-time firmware engineer at VIAM. So I do firmware for embedded devices, audio and visual communication stuff, like the things that make me sound cool. I'm also the internal developer at our school's radio station, WITR 89.7. Give it a listen. I'm very much plugging that. Also a metal show. So yeah, y'all like metal, hit me up. And I'm evil. Yeah, that's just kind of how it be. Oh, one sec. Issue on this part too. Who would have known? All right, so I've been programming for a while, and I started off with Java. And as a young teen, I started programming in Minecraft. Who would have known? And after a while, I became... It went black. We're back. We're so back. We're so back, guys. All right. So I became accustomed to the form Spigot, which is a Minecraft server platform. And lots of new programmers ask questions about pretty much anything, usually server plugin related. And answers often carried some kind of opinion to them, whether it be based on your skill set, personal experience with the problem at hand, or if you have additional context to something. And that's great. It can provide healthy debate to get a better final answer, which is just great. However, when it comes to the question of, oh, hey, I'm a new programmer, what IDE should I use? All logic, reasoning, anything goes out the window. And it's awful. This is in the actual picture of what a debate looks like of the IDEs. It's terrible. Yeah, it's awful. So, yeah, in real life, they're usually a little bit more chaotic than this. Oops. But you get the idea. So people would suggest things like IntelliJ, VS Code, NetBeans, BlueJ, and even Eclipse. Whatever. But most of those are viable options, and they all have their upsides and downsides. But no one wanted to hear that at all, ever. In the midst of the chaos, though, there's a ray of hope. There's a lighthearted joke that seemed to bring people together like nothing I'd ever seen, and that was the phrase, I program in Paint. And this is just like, a little funky with this, getting used to it. But nothing could tear you away from the anger and rage of these heated arguments than this ridiculous phrase. This asinine idea of programming in Paint was tossed around so much for years, and it was just funny. That's pretty much it. So I'd seen this brought up so many times throughout the years, and it made me think to myself, like, what if I made that happen? Might be kind of cool. So I stuck the idea in my little ideas.txt folder, and it sat there for about a year, and I did nothing with it. And one weekend in late 2017 rolled around, and I'm like, you know what would be funny? If I made that Paint thing. That would be kind of silly. So I got to work. That weekend, I whipped up a little Java program that could do all the things that you'd expect an IDE to do. It could highlight Java code. It could compile and run Java. And it could recognize black 12-point Verdana font rendered by Windows 7 MS Paint. The typical things of an IDE, you know. So this program basically allowed you to very crudely write code in Paint. And I will elaborate on the 12-point Verdana rendered by Windows 7 MS Paint. But it could do some like silly little stuff. It wasn't pretty. This is what it looked like. Very much a 2017 Java program made in a weekend. But you can see it does some cool stuff. It has some buttons for syntax highlighting, compiling, whatever, fun things. And the only thing left to do was post it to a forum. So I did. And this is the example of one of the like highlighted output files of this. Not too pretty, but it works. It's highlighted. And it could even do some error detection, so some little diagnostics. So this is an example. All these are rendered by the IDE itself. So this is it missing a semicolon. So cool, it could do that. And what do you know? People liked it. People really liked it. So I had never really made anything that had like a growing audience. Granted, this was not a big audience, whatever, but it like kind of got me thinking. I'm like, okay, so let's make this better. So before I get into the technical side of how the IDE could actually become better, some stuff happened before adding the majority of stuff. So on and off over the course of the year, the most obvious upgrades were added. Git support and a better UI to make it look pretty. This is the new UI, so definitely an improvement. So not just the dumb little Java program. It's a slightly more pretty dumb Java program. So I made some tutorial videos, and then it kind of started actually going up. So this little website that I made for it got what some might call the Hacker News hug of death a couple of times. So that was not too fun. Thank you, Cloudflare, for saving me a lot of money in network traffic. But from here, I realized maybe I should make the IDE itself better rather than making it look prettier. Who would have known? So one of the reasons I'd been avoiding this is because the actual technology behind it is terrible. It's really bad. So why was it bad, you might ask? The most obvious answer is the OCR, which is the optical character recognition. And this basically allows it to actually read the characters from an image. So remember how I said the IDE could recognize 12-point black Verdana rendered on Windows 7? Well, that was a hard limit with absolutely no variation at all. Had to be Windows 7 too, due to the way that Windows 7 rendered characters. And to understand why, let's take a sneak peek into a nice folder named Letters in the original IDE. So this is, you might be able to guess, is a bunch of letters and numbers and any symbol that the IDE could identify. And there's 0 through 9, there's uppercase, lowercase letters, all that fun stuff. So how might these letters be used, you might ask? Well, as you know, a great OCR does, it goes through that letters file and it checks every single possible location in the image for every letter. And once it finds a character that it matches with, exactly, pixel to pixel, then it keeps track of that. So it says like, oh yeah, like it's right there, that's cool, keep track of the position. And then after all that, it compiles it down into actual text. This was awful. This was a terrible approach. It was the very first thing that I thought of, like, oh yeah, how could I like very quickly just put like detect letters, and that's it. So like this training image took about 3 full minutes for the IDE to read. And that's not good. That's really not good. The new IDE could do that in about 100 milliseconds as a little comparison. So yeah, not great. I even tried this, like this had to work on Windows 7. Every time people like were talking about using it and stuff, they didn't have Windows 7. I know they didn't. No one did but me. But it is what it is. So how could it be better? Kind of a lot of reasons for that. The first obvious thing is the OCR. It's terrible. It needs to be robust. It needs to work across many systems, fonts, and not take a million years to process. The next thing is that this integrated development environment is not integrated. It's barely a development environment, but like it needs to be integrated. That's kind of a core thing when you think of an IDE. The next thing is the ability to refactor. And like renaming a word in a paint file is not easy because you have to like delete it and then you have to move stuff around. It's really not good. It's pretty terrible. And PNGs don't have like any access to what a text box is. It's just a bunch of pixels. So what are you gonna do? it's actually a pretty trivial problem solving this once you solve some other issues with the IDE. And another big thing is the language server. So I don't want it to just detect Java. Like reading Java, that's boring, no fun, and it didn't even do it well. So that kind of has to be dealt with. We'll get into that later. So for those familiar with an OCR is, you'll probably know that there's a bunch of different ones out there. Big ones being something like OpenCV, Tesseract, the list goes on. So why make an OCR? That's a dumb idea. I get asked this question a lot. Those work in most cases. However, this is not most cases. It doesn't fit the use case of the IDE. Why might that be? This needs to be 100% accurate. If you're one character off, say if the letter L is detected as a pipe, which OCRs don't really care about usually, your code's probably wrong. It's code. It's not just reading stuff, so it needs to be right. Also need to be able to extract some kind of metadata from this. So you need to get the exact font size and character positions of everything for further imagery construction, which we'll talk about later. You also need to include spaces. I don't know of any OCR really. I mean, I haven't done any research since now, but no OCR detects a space, because why would you want to do that? You don't want to read space. Code isn't just text arbitrarily positioned on the screen. If you're writing something like Python, you know this, because you need your spaces, which MS Paint IDE can do, of course. So now that we have some constraints for the OCR, let's check out how it actually works. So the OCR's functionality is broken up into two different parts, or two different chunks, I guess. Training and detection. Training basically tells the OCR what the characters look like, or what to think about of a character, because it has no clue what it is. And detection is actually reading an input image. The way training works is once you get a font that you want to detect, then you can make a training image, which is just a bunch of strings of all the possible characters that you can detect of a bunch of different sizes. So the reason for all the different sizes is because it basically gets it'll calculate some stuff, which we'll go over in a second, but it averages a bunch of stuff together to get the most accurate result that'll work with most font sizes. So the OCR is actually able to read much smaller and much higher font sizes than the actual training image is given. It doesn't have to be this many strings. I just did it because it kind of looked cool. Whatever. But yeah, it might not make too much sense now, but let's get into what the actual characters mean. So characters are selected, or let's take this letter E. So characters are grouped by combinations or grouping of like black pixels. So things like a letter I might use some other calculations of detecting if the like dot is actually part of the rest of the I, whatever. But this is a nice simple example. So the first step is to break the character into 17 different chunks. So on the left and right sides, the chunks are the same size always. And the reason for the multiple sizes is because breaking a character into chunks, if it's a small font, you can't really break pixels up that evenly. So this just makes it a lot easier and more manageable to deal with. Next, you go from each chunk, and you basically get a percentage of the black pixels to white pixels in the chunks. And you put them in a corresponding array. So every character is calculated the exact same, all fun stuff. So the arrays can be compared later on. Some other data, like width and height ratios, stuff like that, is also recorded. Whatever, fun stuff, just makes it more accurate. And all this is just thrown in a database. So database looks something like this. It has some more data in it, but you basically have like, for the E, you're gonna have like actually training, say like a dozen different E's. You just do an average of every different array index, all fun and games. So yeah, that's what that looks like. So now that we have training done, we can get into detection. Detection is as simple as calculating the chunks before and comparing it with the database to find the most similar array. So I'm very sorry to throw a formula like this at you. I hate it too. But this is the comparison between detecting a character's calculated thing, so your input image, let's call that A, and the one in the database, which is B. Why this is squared and not just an absolute value, I have no clue. I don't know, probably just a botched distance formula. But I don't know, it works. So let's get into an example of what this actually looked like. So at this top here, we have a character that we don't know what it actually is. So we have a bunch of calculated results, and we have to figure that out. So applying that formula to every item in the database, we get something like this. So this is the difference between every character and the detected character. So you can see here that E has the lowest difference. So it's most likely E. And some other factors like width, height, whatever are at play there, but that's the main detection algorithm. It's not really complex. This is an amalgamation of a bunch of different stuff that was researched. In the wiki, you can find some sources for that. Fun things. Yeah, so now we have OCR. The reason why the chunks work so well is because every chunk is unique enough to each character, so it can be reliably compared. So the next component is refactoring, which goes hand in hand with the actual OCR. We're going to stick with renaming things because that's just like easy. So how could an image's text be manipulated, you might ask? So the first step is to read the image. So you read the image, get all the text, fun stuff. You manipulate the string. So you can do whatever renaming thing you would like. I don't know, do regex, talk to the language server, whatever you'd like. And then adjust the coordinates of the characters based on the font sizes recorded from before. So we'll see an example in a minute, but you basically want to make sure everything is positioned properly. If, say, a string is shorter than the original. And then you just rewrite the image. So this is actually able to, with this OCR, you can make a very, very accurate image to the original, which is quite cool. So let's see this in practice. So let's take an input image right here. So this is just a super simple Java class. It's printing out something from class stuff, cool things. So let's replace stuff with something. So from the OCR, we know that this is in Comic Sans. It's in 48-point font, and stuff starts at about 164,380. So knowing this, we can, if we replace the characters without adjustment, we get something like this. So this is why adjustment's necessary, because you don't want something like that. That's ugly. It might work, but no, that's not going to work. But after adjustment and rewriting, it can produce a final image like this. So all these images are actually produced by the IDE. These are taken from the wiki, actually. But yeah, you can replace things quite easily, and you can make a near-perfect representation of the new image, which is quite cool after reading it through the OCR and all that. So this is what the actual thing looks like in the IDE, if anyone's curious. Just a super simple find and replace window. It works, fun stuff. Now that we have refactoring, let's get into integration. So the IDE has to be integrated because you actually want to do stuff with it. So what might integration look like, considering our development environment is literally Paint? Like modifying the binary is possible, however, that's too much work. Whatever. This is high school me. I don't care. So it might look something like this. So these are a bunch of buttons that are seemingly built into MS Paint. They act normally. You can hover over them, click on them, all that fun stuff. So this allows you to build, run, stop the current program, along with some get actions like commit, pulling, and pushing. And then if you hover over something, then it says some little text at the bottom. So how the hell does this work? Because without modifying the binary at all. So this uses a fork of a project by my friend Nick. Hi, Nick. But what this allows you to do is add buttons into the title bars of windows. So what this does is it creates a transparent window on top of that, locking its position on top of whatever parent process it is, in this case, Paint. And you can just add different components and stuff to it. It can't actually interact with the underlying window. However, it's pretty seamless. So having a library like this is super great and all. However, it's C#, and MS Paint IDE isn't Java. So how are we going to do that? This is where we get into the wonders of JNI. So JNI stands for Java Native Interface, which is Java's form function interface framework, which might sound like word jumble, but it's actually a pretty simple concept. So a foreign function interface allows for a programming language, in this case Java, with JNI, to call functions and share resources with another programming language, allowing for interoperability. So what does this actually look like in practice? So it looks something a little like this. So this is a simplified version, or a simplified outline of the communication between the C# and Java of the IDE. So we can see a fork of open title buttons, or open title bar buttons, is used as a library for paint injector, which is just another binary that was created for the IDE. These are all packaged in a DLL, which is essentially a non-executable shared objects file for Windows. Fun stuff. So in Java, you're able to load this file as an interface, which is pretty cool. So the actual code looks something like this. So we have C# and Java here. JNI with C# is a little funky because it just is, I don't know, Microsoft Java, who cares? However, using the DLL export decorator by some package, you're able to do it pretty easily. So all you really need for something like this is matching function signatures. So it's really not hard at all. The reason why there's a bunch of callbacks in here is because most of the functionality between the IDE and Paint is from Paint interacting with the IDE. So like you click a button in Paint, tells the Java program it's something, that's what the callback. So yeah, it's really not hard at all. And next up, now that we have it all like integrated and everything, the code doesn't know what code is. It knows that it's text, and that's about it. It can rename stuff, cool, whatever, who cares? This is the only thing so far that an actual IDE, well, a normal IDE, I suppose, would actually have to worry about. So a language server, what is a language server? So it's generally a separate sibling process to the IDE that provides code completion, linting, refactoring. We don't care about code completion because whatever, don't care. But it allows an IDE to utilize an actual language. So the way a language server works is it uses the language server protocol over inter-process communication. So either through like sockets or I/O, whatever you'd like. I can do pretty much anything. So what's great about this is that the language server can be written in any language, and using a library, or if you implement it yourself, you can write it in whatever language you'd like. So the IDE doesn't actually have to be rewritten for every language that you use, which is quite nice. So first thing to get off my chest is that this was painful to implement. It's awful. I did not enjoy this one little bit. I had some help from a little nice guy from Red Hat, which is kind of cool, but like it was awful. So why is that? It's all images. Language servers sometimes do file I/O or something. They probably interact with the file somehow. And these aren't normal files. These are literally PNGs. So they don't expect you to not have text. This can be gotten around by creating either temporary files when it actually wants to access something, or directly feeding it the text that it wants to have. Next is the IDE isn't that integrated. Code completion, jumping to definitions, think again. That's not going to happen with this. Is it possible? Kind of, yeah, but that's a little out of the scope of this. There's such a disconnect between the program interface and the rest of the IDE. It's hard to implement a lot of functionality using LSP. And the last thing is that there's a really steep learning curve to this. It's really complicated. There's a lot of docs for everything, but it's a very fine line of what needs to have simulated functionality and what can just not be included at all, at least with MS Paint IDE, because it's Paint. So yeah, fun stuff. So what does communication actually look like in LSP? So we can see here that we have MS Paint on one side, language server on the other. The communication's done through any means you really want, some kind of IPC. So the IDE says, oh, hey, I modified a file. Cool stuff. Language server, like, all right, here's your diagnostics. That's pretty much it. It's really not that complicated. Well, in theory, it's not complicated. In practice, little different. Oh well. So I did go a lot faster than I expected. However, it is kind of information dense. So I didn't include a lot of stuff about the IDE. So what wasn't covered? Let's see. Biggest thing is syntax highlighting using something called Antler. So this is not actually handled by the language server. What Antler allows you to do is it's a tool to tokenize and parse grammar made for languages, allowing it to actually highlight any supported language. So you can make your own languages. It has support for pretty much anything. You just have a grammar file, some fun stuff. The next absolutely essential feature I didn't cover, kind of should have, is Google Assistant support. I know that I can assure you that all you cybersecurity folk can agree that there's nothing better than relying on a smart home device for trivial tasks. You need it. So it's great. You can be like, oh, hey, Google, run my code. It's like, all right, and then it runs. So that's quite nice. That's essential. I don't know why more IDs don't have that. Eclipse definitely doesn't, that's for sure. Another thing is Discord RPC, which is essential because that you could show everyone that you mean business when you're programming. So yeah, do you need that? Definitely. Another thing is the native Windows installer. It's nothing special now. However, MS Paint IDE was able to leverage Java's J package during its initial incubator release in JDK 12 a while back, years before it actually became stable, which is quite cool. Which allows you to make a Java program into an executable, basically, by packaging its own JDK, which is quite cool. Thank you. So, yeah, fun stuff. I'll take questions in a sec. However, if anyone's interested in how the OCR actually works, there's an extremely detailed wiki about how everything works. It goes almost line by line through it. So you can implement it without knowing Java at all, just by reading it, or something the exact same. The actual MS Paint IDE website, mspainti.de, is actually down because my VPS got hacked. So I know, boo. Best people to tell that to. But I was in Vermont with no reception, and I came back to my host saying, "Hey, there's malware." I'm like, "Oh, uh-oh." So yeah, cool stuff. Hit me up about anything. I love talking about this kind of stuff. There's an entire organization of about a dozen or so repos for the actual IDE that are used. And yeah, thank you. Any questions?
Can you run this on Linux?
You could. You could not run with the installer. However, I think you might be able to. That might still be an ongoing issue with the IDE, like on the repo. So who knows? If you do it, let me know.
Okay.
Question in the back there, young man.
What was the overall time commitment like for this? Like how many hours you spent working on this?
In the 4 digits. I wish I was joking. This was like, I worked on the OCR for consistently 10 months, and that was about 12 hours a day. It's not good. The rest of the IDE is a different story because that's a whole nother beast. However, the time commitment is embarrassing, and yeah, this has no real purpose other than being funny, which I think is kind of worth it. So, yeah.